concave up. Okay, so F is said to be concave up. Okay, so F is said to be concave up on interval I. Okay, so F is said to be concave up on interval I if F prime is increasing on I, and F is said to be concave down on the interval if F prime is decreasing on the interval. Okay, so for theorem F double prime X greater than 0, then F is concave up, and if F double prime less than 0, then F is concave down. Okay, so ni example of the concave down. Okay, and then this one is example of the concave up. The turning upward, so ni turning downward. Okay, so to determine intervals where the function is concave up or concave down, okay, so for example, we have function fx. So determine interval concave up and concave down, we can use f double prime. Okay, so f double prime x you equalkan with 0. Okay, so you will get value of x. So from value of x ni, you boleh form interval. First you have 0. First you choose less than 0. Another one is greater than 0. Okay, so for less than 0 is negative infinity until 0. For greater than 0 is 0 until infinity. Next, you substitute test value. Okay, so for this example, we choose negative 2 and 2. And next, substitute into the f double prime x, and you refer to the symbol or sign of f double prime x. So sign is negative, so another one is positive. So if f double prime x negative or less than 0, so the fx will be concave downward. Okay, so if f double prime positive or greater than 0, then fx will concave upward. Okay, so ni untuk concavity. So for example A, you can refer to the recorded video. Okay, for inflection point, okay, so for inflection point, definition, if f is continuous on an open interval containing value x0, then f changes its concavity at x0. Then f has an inflection point at x0 and f of x0. Okay, so ini for the inflection point. So definition of the inflection point is the point where the concavity changes. So for example, you can refer to this diagram. First, we have concave up and we have concave down. So, point yang center between concave up and concave down, so tempat yang pertukaran concavity, so kita panggil inflection point. Okay, so the same goes for this one, concave downward, and we have concave upward. Okay, so this point we call as inflection point. Okay. So example 9 also you can refer to recorded video. Okay, saya nak move straight to example 12 nanti. Okay, so saya nak you refer to sketch the graph of polynomial function. Okay, the first step you need to analyze fx. Okay, find the x-intercept and y-intercept. And step 2, you need to analyze f prime x. Okay, first find critical numbers, construct sign table for f prime, and determine the intervals where fx is decreasing and increasing. And number 4, find the extremum points. Okay, and step 3, so for step 2 ni, you need to analyze f prime. So f prime relate with increase or decreasing function, and increase or decreasing interval, and also relate to extremum problem. So kita ada two things yang relate with f prime x. For step 3, we need to analyze f double prime x. So to analyze f double primes, you need to find the zeros of f double prime, construct a table for f double prime. Next, you need to determine the intervals where fx is concave up and concave downward. Okay, so for f double prime, they relate with concave upward and concave downward. Okay, and also relate with inflection point. So these two ni relate with f double prime. Okay, and step 4, we need to sketch the graph of fx, mark and label all important points. So important points ni refer to the x and y intercept, extreme point and also inflection points. Okay, so semua points ni you kena letak dekat you punya graph nanti. Okay, next we have example 12. Okay, so nak refer straight to example 12. Okay, so consider you have a function, cubic function, negative 2x cubed plus 3x squared plus 12x minus 5. Okay, first you need to find the x and y intercept. Okay, for intercept dia for A, first you calculate x intercept. Okay, so x-intercept is when y is equal to 0. Okay, so from fx, you have cubic function, so you equalkan with 0. So you can find values of x. So nak calculate values of x, you can use calculator je. So from calculator, okay, so x is equal to okay, so x is equal to 3.15 and x is equal to negative 2.04 and last x is equal to 0.39. Okay, so 0.39. So this one for x-intercept. So we can find the coordinate there. Coordinate for x-intercept is 3.150. Next we have negative 2.04, 0 and 0.390. Okay. Next we find the y-intercept. Okay, so the y-intercept is when x is equal to 0. So substitute x, substitute 0 dalam fx, so you will have negative 5. So the x-intercept point, the y-intercept point is 0, negative 5. Okay, so you have x and y-intercept. Next for b, yeah.
Kalau ada imaginary number tak payah ambil ya?
Tak payah ambil. Imaginary number tu you ignore je. Kita ambil yang real root je.
Okay, madam.
Okay, sebab calculator dia akan bagi kan, dia akan state mana yang imaginary, mana yang real. So kita ambil yang real.
Okay, madam.
Okay.
Faham. Thank you.
Lepas tu for B, okay. So for B, the intervals on which fx is increasing or decreasing. Okay. So B kita nak determine interval increase and decrease. So kita refer to the condition of the critical numbers tu. Okay, when f prime x equal to 0. So ni you kena ingat, bila you nak calculate interval increase or decrease, okay, kita akan start dengan calculation of the critical numbers. Is when f prime x is equal to 0. Okay, so you differentiate, you will have negative 6x squared plus 6x, okay, plus 12. Okay, equal to 0. So you calculate values of x. So ni pun you boleh calculate using calculator. So x is equal to negative 1 and x is equal to 2. So negative 1 and 2 ni is a critical numbers. Sekejap kan. Okey, kejap ya. Saya nak kejap. Okay, so kita continue. Kejap Okay, so kita continue with, okay. Okay, so for B, critical numbers is x equal to -1 and x is equal to 2. So from these critical numbers, we can form sign diagram. So we have -1 and 2. So sign diagram to nak determine interval, first you choose yang less than -1 and between -1 and 2. So last is greater than 2. Okay, so you punya interval start with negative infinity to -1. Next we have -1 until 2 and 2 until infinity. Okay, so substitute test value. So test value you can choose any numbers yang dalam interval. From less than -1, for example, I choose -2, between -1 and 2, so I choose 0, and greater than 2, I choose 3. Okay. Next, after you have test value, substitute into f prime. Okay, so saya nak refer to sign of f prime x. Okay. Okay, so you have fx. Okay, so sign for f prime, substitute -2 dalam f prime. Okay, so you will have negative. So kita nak tengok simbol dia je. So substitute kat sini f prime. Lepas tu substitute 0, we have positive. And substitute 3, we have negative. Okay, so when f prime negative, so fx is decrease. Okay, so when f done. Okay, so when f prime is positive, we have increase, and when decrease, when negative, okay, so fx is decrease. Okay, so you can conclude fx is decreasing on negative infinity, -1, and 2 until infinity, and decreasing and increasing, and increasing on -1, 2. Okay, so yang ni you punya interval increase and decrease. Next, for C, you need to find the maximum and minimum. Okay, so relative maximum and minimum, kalau you refer balik yang previous lecture, okay, kita ada dua method. You can use first derivative test. Okay, first derivative test, and we can use second derivative test. Okay, so ni saya pakai first derivative test dulu. Okay, so first derivative test kita akan refer balik pada sign diagram. So based on the sign diagram, kita ada decrease, lepas tu dia increase, lepas tu dia decrease balik. Okay, so kalau you refer kat sini, bila dia decrease sampai x equal to -1. Kalau you refer interval dia. Lepas tu dia akan increase until x is equal to 2. Okay, so automatic you dah tahu minimum point dia is when x equal to -1. Okay, so maximum point dia is when x equal to 2. Okay, so you tinggal nak calculate y je. So for y, you nak calculate y, substitute balik value of x into fx. Okay, so when x equal to -1, so substitute into fx ya. Kena yang substitute dalam original equation dia. Yang equation asal. Okay. So substitute dalam fx, you will have -12. And when x equal to 2, so f2 is equal to 15. Okay. So you can conclude relative minimum is -1, -12. So yang ni is a relative minimum, while 215 is relative maximum. Okay, so yang ni saya solve using first derivative test. Okay, so you boleh juga solve using second derivative test. Okay, so saya tunjuk juga untuk yang second derivative test. Okay, for C, so C ni saya buat balik tapi saya pakai second derivative test. So mungkin ada yang prefer pakai second derivative. Okay, so kalau second derivative test, first step dia sama juga, you kena calculate critical numbers tu. Maknanya you kena ada f prime x equal to 0. Okay, lepas tu you differentiate, you will have -6x square plus 6x plus 12 equal to 0. So x equal to -1 and x is equal to 2. Okay, so kalau you refer dia sama je step macam sebelum ni. You kena calculate critical numbers dulu. Okay, tapi kalau first derivative test, after you calculate critical numbers, you buat sign diagram. Tapi kalau you use second derivative test, after you ada critical numbers ni, you boleh terus proceed to second derivative. So you differentiate lagi sekali, dapat -12x plus 6. Okay, lepas tu you need to substitute x2 with the critical numbers. So you have -12, -1 plus 6. So you will have greater than 0. So greater than 0, kalau you refer theorem, if f double prime greater than 0, then you will have relative minimum. Lepas tu you substitute lagi x2 with 2. So you have -12, 2 plus 6. So you will get less than 0. Okay, so based on the theorem, if f double prime less than 0, then you will get relative maximum. So relative maximum minimum ni dia refer pada value of the x ni. So maknanya you dah tahu x dia -1y lah. -1y is relative minimum. So when x is equal to 2, so you akan dapat relative maximum. So nak calculate y ni sama macam sebelum ni you buat. Okay, so nak calculate y, substitute je dalam original equation, you dapat -12. So substitute 2, you akan dapat 15. Okay, so nanti dapat 2 point juga, -1, -12. So yang ini is a relative minimum, and 215 is a relative maximum. Okay, so sama je result dia kalau you use first derivative test. Okay, so you dapat point yang sama. Okay, so ni kalau for C, you nak solve for relative maximum and relative minimum using first derivative test or use second derivative test. Okay, next for D. Okay, so for D, you need to find the intervals where the graph of fx is concave up and concave down. So you nak determine concavity, you kena ingat condition dia is when f double prime x equal to 0. Okay, mana you kena differentiate 2 times and equalkan dengan 0. Okay, so saya differentiate lagi sekali. you punya function fx. So you have negative 12x plus 6. So equal to 0. Ni saya differentiate second time. Negative 12x plus 6. And x is equal to 1/2, you boleh form sign diagram. Sama juga you kena form yang interval dulu. So interval you, first you choose yang less than 1/2. Dan the one you choose yang greater than 1/2. Okay. So you have interval. So ni interval for concavity. Okay, you ada negative infinity, 1/2. And another interval is 1/2 and infinity. Okay. So second row you have test value. Okay. And next kita ada sign of f double prime. Tadi kita pakai f prime. F prime untuk interval increase and decreasing. Concavity kita pakai f double prime. Okay, last is for the graph lah, fx. So you choose any value yang less than negative 1. So less than negative 1, for example, less than 1/2. So for example, I choose 0. So satu lagi greater than 0.5. So greater than 0.5, for example, I choose 1. Okay, so substitute adalah f double prime. So kita tengok simple je. So kalau substitute 0, you have positive. If you substitute 1, you have negative. So kalau positif, f double prime positif, fx is concave up. So if negative, concave down. Okay, so jangan lupa conclusion, fx is concave up on negative infinity 1/2 and concave down on 1/2 until infinity. Okay, so ni untuk concavity 4D. You nak determine intervals yang concave up and concave down. Next for E, you need to find inflection point. So inflection point dia relate with concavity. Sebab inflection point ni, X for inflection point sebenarnya comes from yang ini. When f double prime x dia equal to 0. Okay, so terus you boleh calculate inflection point. When x equal to 1/2, so nak calculate y, sama juga macam sebelum ni. Bila nak calculate y, you need to substitute dalam original function dia. So substitute dalam fx. Okay, so nanti you akan dapat 3/2. So you will have 1/2 and 3/2. So yang ni is inflection point. Okay, so dia dah complete lah. So kita dah ada semua point dia. Next kita boleh sketch graph. Okay. Next, okay, so using the above equation, sketch the graph of fx. So kita nak sketch graph. So tak perlu sketch dalam graph paper, you boleh sketch dalam you punya test pad ataupun dalam A4 paper pun boleh. Okay. Okay, so sketch graph, we start with x and y axis. Okay, so you have x and y axis. First you draw the y and you have x axis. Okay. Lepas tu you listkan x intercept dulu. Okay, so x intercept tadi you dah calculate, you ada 3.15. Okay, so for example 3.15 kat sini. Okay, 3.15. Lepas tu you have 0.39. So 0.39. And you have another one is negative 2.04. So for example kat sini, negative 2.04. Okay, so ini for x intercept. Next, you plot for y intercept. Y intercept tadi you calculate dia equal to negative 5. So y intercept dia kat bawah ni negative 5. Okay. Next, you dah ada x and y intercept. Next, you can plot for minimum and maximum. So minimum tadi, you have -1, -12, and maximum you have 215. Okay, so you plot dulu -1, -12. So -1, -12, so dekat bawah ni. Okay, so yang ni for -1, -12. Next, kita ada maksimum dia 215. So 2 and 15. Okay, so you have 215. Okay, lepas tu, so ini is minimum. Okay, so ni punya minimum, and this one you punya maximum dia. Okay, so nanti boleh sambung ke titik dia. Okay, so ini you punya graph. So dia mesti lalu semua you punya intercept tadi. Okay, so dia mesti lalu pada y-intercept, lepas tu pada x-intercept, sudah akan pergi kepada maximum point dia. Okay, tu you turun balik pada 3.1. Okay, so nanti you buat cantik lah. Ni saya tak pandai lukis pasal pakai benda ni. Okay, so nanti you buat cantik sikit, dia graph dia smooth dia sebab dia graph cubic kan. So dia graph smooth So you have y. Okay, so ni roughly lah graph dia. Okay, so inflection point you kena plot juga for inflection point. Inflection point tadi kita ada inflection point is 1/2 and 3/2. Okay, so inflection point dia dekat center between concave up dengan concave down. So kat sini lah. So ini is 1/2 and 3/2. Okay, so yang ni function fx. Okay, so ni for graph for example 12. Okay, ada soalan tak? So far, for curve sketching.
No, madam.
Okay, so sketching ni senang je sebenarnya. So kalau keluar patutnya you boleh dapat full mark. Sebab dia tak perlu, dia calculation dia calculation simple, cuma dia panjang, dia step dia ada banyak sikit lah. Tapi dia senang je. Okay. So ni untuk curve sketching. Next. Okay, so saya nak masuk yang last part of chapter 2, extreme problem. Okay, so 2.3, we have extreme problem. Okay, so definition. F of A is said to be an absolute maximum for f of x if there exists a number A such that f of A greater and equal to f of x. Okay, so yang ini is the definition of the absolute maximum. Okay, so and for absolute minimum is when f of A is less and equal to of f of x for all x in the domain of f of x. Okay, so we have step there. So step to determine the absolute maximum and absolute minimum. We have 4 steps. Number 1, find all the critical points. Ini macam biasa, when f prime x is equal to 0, nanti you akan dapat critical point. For number 2, calculate the value of f of x at critical point. So ni sama macam nak calculate value of y lah. Kalau sebelum ni untuk graph tu, kita nak calculate value of y bila you ada critical points dia. Okay, tapi kita ada 2 additional step dia. You ada find value of fa and find value of the fp. So yang ini value pada interval and number 4, the highest value in step 2 and 3 is the absolute maximum and the lowest value in the step 2 and 3 is the absolute minimum. Okay, so for extreme problem ni kita kena consider interval juga sebab dia contoh saya bagi you example in terms of graph, nanti senang sikit you tengok. Okay, so kalau in terms of graph, okay, so for example Okay, so saya ada this graph. Okay, contoh dia. Okay, so saya ada macam ni. Okay, so this graph is between interval A and interval B. Okay, so you have between A and B. Okay, so atas ni is a relative maximum and bawah ni is a relative minimum. So for example, absolute maximum minimum ni kita nak calculate value pada Y. Okay, so you ada Y1 and you have Y2. So to Y1 and Y2. Okay, so for sekejap okay. Okay. So based on this graph, the highest value at the Y is Y1. So Y1 ni we call as absolute maximum and the lowest value pada Y, so Y2 ni kita panggil as absolute minimum. Okay, so absolute maximum ni maknanya kalau between graph tu, dia value yang paling tinggi sekali and absolute maximum tu value yang paling tinggi, so absolute minimum ni value yang paling rendah sekali. Okay, tapi kita ada juga condition dia ada certain situation dia jadi macam ni. Okay, you ada graph, so dia macam ni. So dia between A dengan between B. Okay, tapi yang lowest dia bukan pada maximum or minimum, tapi lowest dia pada interval. So kat sini saya assume as Y2 and then this one is Y1. Okay, so kalau case macam ni, Y1 dia is also absolute maximum, tapi absolute maximum dia pada interval B, pada end of the interval. Dia boleh juga jadi Y2. So Y2 is the absolute minimum. So absolute minimum tapi dia pada interval A ni. Macam yang atas ni, absolute maximum dia also equal to relative maximum. So absolute minimum dia equal to relative minimum yang bawah ni. Okay. Sebab tu kita kena consider juga you punya value pada f of A dengan f of B. Baru you boleh determine mana satu yang absolute maximum or absolute minimum. Okay, boleh Okay, so 2.3 saya nak move to example 16. Okay, yang try me example. Okay. So for example 16, okay, you have a closed cylindrical drum is to hold 1000 liter of liquid. So what is the height and radius to minimize the amount of material needed to manufacture the drum? Okay, so for semua problem ni, keyword dia you kena refer to minimize or maximize. Apa yang you nak minimize kan ataupun apa yang you nak maximize kan. Okay, so kalau untuk example 16 ni, dia nak minimize kan amount of material needed. So for example, you have drum. So drum tu in terms of cylinder. Okay. So dia nak minimize the amount of material. So maknanya dia nak minimize kan the surface area dia. So dia tak bagi tahu direct lah. Okay. Tapi sebenarnya dia nak minimize kan yang surface area. Sebab material ni makna material you buat drum ni. So dia punya surface area tu. Okay. So you need to know what is the formula of the surface area. So surface area of a cylinder, so formula is equal to 2 pi r square plus with 2 pi rh. Okay, so kalau you refer to step tadi, kita ada 4 step. First step dia nak you determine the critical numbers. Okay, so kita nak determine the critical point tu ataupun critical numbers. Kalau you refer balik yang previous class, bila nak determine critical numbers, you mesti ada f prime x equal to 0. Maknanya first derivative dia, you kena equalkan dengan 0. So sama juga dengan ni. Okay, you kena differentiate dia, mesti equalkan dengan 0. Tapi kalau you refer to area of the formula of the surface area ni, pada right hand side, kita ada 2 variable r dengan h. So better you tukar dulu in terms of one variable. Nanti senang you nak differentiate. Okay. So you boleh choose you nak tukar semua in terms of R or you nak tukar the whole equation in terms of H. Okay. So for example, saya nak tukar semua in terms of R. Okay. So maknanya saya kena remove H ni. So you nak remove H maknanya you kena ada lagi satu equation. Okay. So another equation you can refer to the first statement ni. Closed cylindrical drum is to hold 1000 liter. So you boleh assume, so you boleh derive equation for volume. So volume for cylinder, formula is V equal to 1 over 3. Oh sorry, so V equal to pi R square H. Okay, so V saya ambil in terms of this one lah. The cube, you ada 1. Okay, so equal to pi R square H. Okay, so from this equation, saya boleh derive H. So H is 1 over pi R square. Okay, so substitute kat sini, equal to 2 pi R square plus 2 pi R. So substitute H with 1 over pi R square. Okay, so equal to, you simplify. Okay, equal to 2 over R. Also equal to 2 pi R square plus 2R negative 1. Okay, so from S, you boleh calculate ds over dr is equal to 0. Ni saya nak determine the critical number. Okay, so differentiate respect to R, you have 2 pi. Okay, 2 pi is a constant, differentiate R square is 2R, plus with 2 is a constant, differentiate R negative 1 is negative R negative 2. So you equalkan dengan 0. So simplify 4 pi R minus 2 over R square equal to 0. And you will get value of R. So R is equal to 0.54. Okay. So when you have value of R, so you dah ada value of the radius. Next, you need to calculate what is the height. So nak calculate height, substitute R dalam equation of height ni. So 1 over pi. So substitute R with 0.54 meters, 54 square. Okay. So you get value of H. H is equal to 1.09. Okay. So ni you punya answers lah for radius and for height. So yang ni tak perlu calculate pada interval sebab dia tak ada bagi any interval. Contoh kalau dia bagi interval, baru you calculate lah pada interval. Okay. So ada soalan tak? For assignment problem.
Madam,
Ya.
nak tanya. So kalau kita nak tahu solution ni macam mana kita nak selesaikan, yang mana satu kita kena tengok keyword dekat minimize dengan maximize lah. Maximum.
Betul. Kena tengok maksimum. Macam yang ini, macam example 13 ni, dia direct sebab dia tak ada bagi dalam bentuk problem solving kan, dia bagi bentuk function ni, so ni betul tengok direct lah. Kalau macam ni, untuk example 14 ni, dia nak to maximumkan profit. Maknanya you kena tahu equation for profit lah. So dia nak maximumkan profit. Macam kat sini dia dah bagi kod profit dia. So D ni profit kan. So maknanya you kena tahu equation for profit. So ni dia punya profit. Price dia. So maknanya equation of profit nanti, bila you dah tahu equation profit, baru you boleh differentiate. Sebab kita nak differentiate tu, you nak differentiate kan, f prime x equal to 0. So nak differentiate ni, dia mesti refer pada you punya main equation. Kalau dia nak maximum profit, maknanya you kena differentiate yang profit lah. Kalau dia nak macam tadi, dia nak minimizekan surface area. So you kena differentiate yang surface area tu. Yang ni pun sama. Dia nak find the dia nak largest volume. Maknanya dia nak maximizekan the volume. Sekarang ni main equation you volume lah. Sebab kalau tu you punya equation, you punya soalan tu dia ada banyak variable. Kalau you tahu you nak equation you nak apa. Sama macam example 16 tadi. Dia ada equation untuk volume. Ini volume punya. Tapi dia juga nak surface area. So you jangan tersilap. Saya tak nak you terdifferentiate yang volume ni. Sebab kita bukan nak volume, kita nak yang surface area. So bila you nak differentiate tu, you kena differentiate variable yang betul lah. Apa yang dia nak tu. Sorry. Macam ini dia nak largest volume. So you kena ada equation for volume. Lepas tu you kena differentiate equation of volume. Okay. So tu kalau you tengok example yang 15 ni, kalau you tengok recorded video, dia differentiate yang formula for volume. Okay. Sebab kita nak maximizekan yang volume tu. Okay. Boleh?
Boleh, Madam.
Madam,
Ya.
yang example 16 tu kan, kalau dia tukar soalan jadi to maximize, ada beza ke?
To maximize. Dia akan sama je solution dia. To minimize
dia sama je.
Solution dia sama je. Sebab kita tak perlu determine, you tak perlu proof. Dia hanya minimize tu. Dia kalau you nak proof boleh, tapi you kena proof pakai second derivative. Nanti you boleh tengok. Tapi soalan ni saya tak perlu proof lah. Sebab rasa dalam recorded video tak ada proving kan. So kalau tak ada proof ni, you hanya tengok je nak minimize ataupun maximize. You nak minimize ataupun maximize kan apa yang equation dia, tapi solution dia sama je kalau you nak maximize ataupun minimize. Okay, so dia tak ada bagi interval apa-apa. Okay, dia kalau you nak proof tu sebenarnya you boleh pakai second derivative. Kalau contoh you differentiate kan, you differentiate yang ds over dr ni, you differentiate lagi sekali. Contoh d square s over dr square. You differentiate lagi sekali, lepas tu you substitute value of r tu, nanti you akan nampak. Dia akan, kalau second derivative test, minimize, dia akan dapat greater than 0. Dia punya second derivative tu greater than 0. So kalau dapat greater than 0, maknanya betul lah nak minimize. Tapi kita tak consider lah proving, so you tak perlu buat proving tu. So you calculate je sampai r, dengan sampai you dapat h. Okay, boleh?
Boleh, Madam. Thank you.
Okay. Ada lagi tak? Soalan lain for extreme problem. Nanti you boleh buat tutorial lah weekend ni. So hopefully tutorial chapter 1 you dah siap lah. Okay, so weekend ni you boleh siapkan tutorial chapter 2. Okay, so kalau ada persoalan you boleh tanya saya lagi. Ataupun tanya you punya tutor pun boleh. Okay, so tak ada apa-apa yang kita tanya. Okay, so kita stop dulu kat sini. Nanti next week kita akan continue with chapter 3. Okay, integration. Okay, so thank you class.
Thank you, Madam.
Thank you, Madam.
Thank you.
Assalamualaikum.
Thank you, Madam.